Lesson 5.6, Equations and Inequalities with Rational Numbers. Now we finished up Lesson 5.5 solving some equations, some two-step equations that had fractions in them by dealing with the fractions, doing the arithmetic with the fractions and then multiplying at the end by the reciprocal. I'm going to show you how to work the same kinds of problems, but by not dealing with the fractions, eliminating the fractions. And the step that we use to eliminate the fractions is that we multiply both sides by the least common denominator. So we look at the fractions that are within the equation or inequality, and it doesn't matter. I have examples of equations. I have an inequality here with the less than or equal to, and I'm going to solve them by starting the steps the same way. I'm going to get rid of the fractions by finding the least common denominator, multiplying every term on both sides by the least common denominator. That's the key step. Every term, both sides. So if I look at the first, I have a half, I have 7/10, I have 4/5. I can tell you right now that my least common denominator here is going to be 10. I'm going to multiply both sides by 10. Every term, both sides by 10. So 10 times this side, and 10 times this side. Both sides, every term by 10. Now on the left side here, I have 10 times the quantity. That's why I put in parentheses. There was a plus. There were two terms, so I have to distribute. I'm going to use the distributive property here. 10 times 1/2 x. Well, half of 10 is 5, so this is 5x plus 7/10 times 10. Now I know it's a little awkward. This is a fraction, this isn't. Put it over 1. And you can see that the 10s would cross cancel, and I'm going to get 7. That's a little tricky. Now the first time I just took half because what this fraction being 1/2, multiplying by half is the same as dividing by 2. So I took half of 10, I just took half of it, divided by 2, I got 5. That's where that 5 came from, and the x follows along. But this is the tricky one. 7/10 times 10. Let me write this again. I put it over 1, I cross cancel the 10s, and I just get 7 over 1. That's where the 7 came from. Now I'm going to do something very similar on the right side, but I'm going to show you a trick. When you're multiplying a whole number times a fraction, if the denominator of the fraction divides into the whole number, and it will every time because we're using the LCD, I'll show you a little trick. You take 5, you divide it into 10, it goes in twice. However many times it goes in, you multiply that times the numerator. 5 goes into 10 twice, 2 times 4, that's 8. And you say, well, how does that work? Well, all I'm doing is cross-canceling. See, I'm just dividing it out. And you can see where the 8 comes from. But that's a nice little trick. It makes the arithmetic go a little faster. Now I have an easy problem. I'm not saying that my answer might not have a fraction in it, but now I have an equation right here, no fractions. So I'm going to solve it like the two-step equations from a previous lesson. I'm going to undo the adding or subtracting first. I'm going to subtract 7 to undo the plus 7. I didn't leave myself much space here, so bear with me, and I get 5x is equal to 1. To get rid of the 5 that's times the x, I'm going to divide both sides by 5, and again, I don't have much space, so I'm just kind of doubling up steps here. And I get x equals 1/5. There's my answer right there. X equals 1/5. Always leave more space than what I'm doing here. Some students like to put one problem per line. That's not near enough room to do these kind. This guy over here, I'm going to approach it the same way. I'm going to multiply both sides by the LCD to get rid of the fractions to end up with something that hopefully will be easier for me to solve. Now my denominators here are 9, 4, and 6. So my least common denominator here is not 9. It's not the largest one like it was back here with the 10 because the 2 and the 5 divided in. It's something a little bit bigger. So is it 2 times 9, 18? No, 4 doesn't go in 18. Is it 3 times 9, 27? No. Is it 4 times 9, 36? That's my guy. These guys will divide into 36. I'm going to multiply both sides by 36. 36 times this side, and 36 times all of that side right there. So here come the parentheses again. There are two terms. Now 36 times -2/9, a positive times a negative is a negative. I'll put the 36 over 1 if it helps, or I can do the shortcut. Let's try that. Let's deviate just a little bit and use the shortcut. I know it's negative. 9 goes into 36 4 times. 4 times 2 is 8. See, that was smooth. Over here, 36 times 3/4. I have to distribute. 4 goes into 36 9 times. 9 times 3 is 27, so this is 27x minus 36 times 1, 6. 6 goes into 36 6 times. 6 times 1 is 6. And I have no more fractions. I'm going to solve this. I'm going to add 6 to both sides. Again, I didn't leave myself a great deal of room. That was my mistake. Negative 8 and a positive 6 is a negative 2. These are going to cancel out, and I get 27x. Almost done. 27 is times the x. I'm going to divide both sides by 27. And I get x is equal to, looks like negative 2 over 27, which does not reduce. And there's my answer. Kind of squeezed it in there. All right, more of the same here. I have to be a little careful with the sign here, but more of the same. Least common denominator, a little bit easier spot here is 12. I'm going to multiply both sides by 12. 12 times the left side, parentheses because there's more than one term, and 12 times the right side. 12 times 1/4, 4 goes into 12 3 times. 3 times 1 is 3, minus 3 goes into 12. I'm distributing there. 3 goes into 12 4 times. 4 times 2 is 8, and there's the x, so I have 8x. Here, positive times negative is negative. 3 goes into 12 4 times. 4 times 1 is 4. Now I'm going to solve. I'm going to subtract the 3. Here's where you got to be careful. I know there's a minus sign there, and you think, well, you're subtracting 3. You're not. You're subtracting from 3. That's a positive 3. I have to subtract 3 from a positive 3 to get that to cancel out. That subtraction sign goes with the 8x. So I'm going to write this as negative 8x. And on the right side, negative 4, negative 3 is negative 7. Almost done. Divide both sides by negative 8. A little more space here. And I get x equals negative over negative is positive 7/8. There's my answer. Now I'm going to work the inequality the same way as I worked the first 3 examples of equations. I'm going to find the least common denominator. I'm going to multiply both sides. Now I'm going to multiply by a positive number. So you may remember if you multiply by a negative, you have to reverse the order. I'm multiplying by a positive number, so that won't happen, at least in my first step. And my least common denominator there with a 2/5, a 3/5, and a 1/3 is 15. So I'm going to multiply both sides by 15. 15 times 2/5 plus 3/5 y less than or equal to 15 times 1/3. A little distributor in here. 15 times 2/5, 5 goes into 15 3 times. 3 times 2 is 6. Plus 5 goes into 15 3 times. 3 times 3 is 9. 9y. Less than or equal to positive times positive is positive. 3 goes into 15 5 times. 5 times 1 is 5. Now it looks a little bit nicer. There are no more fractions. I'm going to subtract 6 from both sides to get rid of the positive 6. I get 9y is less than or equal to negative 1. I'm going to divide by a positive 9, so it is not going to affect the inequality sign. I just don't have much space here, and I get y, I'll put it right here. I get y is less than or equal to negative 1/9 as my answer. Negative divided by positive, negative 1/9. Now let's consider equations or inequalities that involve decimals. Now decimals, remember, are just fancy fractions. Decimals have denominators that are powers of 10. If you think of a decimal like 4.3, that's the 10th spot. This is the same as 4 and 3/10. If you think of a number like 1.77, this is the 10th, this is the 100th spot. This is the same as 1 and 77 100ths. So if you think about it, if you see decimals, think of them as fractions with denominators that are powers of 10. 10 or 100 if there's 2 decimal places, 1,000 if there's 3 decimal places, and so on. So what we're going to do is we're going to multiply by 10 or by 100 based on how many decimal places. We'll look for the most decimal places. And this is the really cool part. When you multiply decimals by 10 or by 100 or by 1,000, all you really have to do is slide the decimal point to the right the same number of places as zeros in that power of 10. If you multiply by 10, it's got 1 0, you slide it 1 place. If you multiply by 100, it's got 2 zeros, you slide the decimal point 2 places to the right. My first example, this has 1 decimal place, this has 2 decimal places, and this one has 2 decimal places. You take the higher amount, in this case it is 2, and I'm going to need 2 zeros, so that means I'm going to multiply by 100. I'm going to multiply this side by 100. And I'm going to multiply the right side by 100. Now the nice thing is I don't have any real traditional fraction work. When you multiply by 100, you slide the decimal 2 places to the right. Now this only has one spot, so I'll put a little placeholder 0 there, and I'll slide it 2 places to the right, and I get 220x. Minus, I multiply 100 times that, it's going to slide it 2 places to the right, I get 364. And 100 times that, it's going to slide it 2 places to the right, I get 846. Now other than the fact that the numbers are 3 digits instead of 1 or 2, it's a nice, simple looking 2-step equation. There aren't any fractions or decimals, and I'll go after this. I'll get rid of the minus 364 by adding 364 to both sides. I get 220x is equal to 0, carry 1, 1, carry 1, looks like 1210. I'm going to divide both sides by 220. I don't have a lot of space, so I'm just going to kind of combine my steps here. Sorry about that. And I end up with x equals, now as it turns out, 220 divides into 1210. I've got to do a little long division. Fortunately, I got a little space up here. And so I'm going to divide 220 into 1210. This is about the time normally I would grab a calculator to make my work a little bit easier. I'm going to add a decimal point and a couple zeros just in case. 220 doesn't go into 1, doesn't go into 12, doesn't go into 121, but will go into 1210 5 times. 5 times 220 is 1100. I subtract 0, 1, 1, and I bring down a 0. Well, you can see decimal point goes straight up my answer. It's going to go in 5 times again. That's 1100. And I end up with 5.5 as my answer. Now, I don't feel bad at all if you decided to use a calculator to do this bit of arithmetic here to save yourself a little bit of time. It's the algebra I'm mostly concerned about here. The arithmetic is a little bit more secondary. It's important, but if you use a calculator, that's not the world's worst thing for this kind of arithmetic. Next problem. This has 1 decimal place, this has 1 decimal place, this has 1 decimal place. I'm going to multiply by 10. That's because it only has, at most, 1 decimal place, and I need 1 0. 10 times 10.5x minus 1.9, a little distributive coming up, and 10 times 19.1. Distributing here, 10 times 10.5, that's going to slide the decimal 1 spot. I'm going to get 105x minus 10 times 1.9. It's going to give me 19. And then here, 10 times 19.1, it's going to give me 191. I am going to add 19 to both sides to get rid of the minus 19. And I get 105x is equal to 0, carry 1, 1, 210. Well, this one's especially nice. I'm going to divide both sides by 105. I'll sneak in that extra step. I should have been doing this the whole time. These cancel out and I get x equals 2. That one comes out without a real messy arithmetic step. Next one up. I have 1 decimal place here, I have 2 here, I have 1 here. So 2 is the most. So just like with example A, I'm going to have to multiply by 100. 100 times 2.3 and 100 times 5.14 plus 0.8x. So that's going to, I need a 0 there as a placeholder. It's going to slide it 2 places. That gives me 230. Here I'm going to distribute. It's going to slide it 2 places. That's 514 plus, add a little 0 here, 2 places, 80x. I'm going to have to subtract 514 from both sides. Hopefully I left myself enough space here. These are going to cancel out. Now, you're subtracting a bigger number from a smaller number, so it's like adding the opposite. So you subtract, take the sign of the bigger, so it's going to be negative. Looks like 284 if I didn't mess up too bad there. And on the right side, I have 80x. I'm going to divide both sides by 80. Kind of skipping a step there. Negative divided by a positive is negative. Now I got to do a little bit more arithmetic. I'm going to divide 80 into 284. Add a decimal point and a couple zeros there. 80 doesn't go into 2, doesn't go into 28, goes into 284 3 times. That's 240. Subtract, that's 4, bring down a 0. 80 goes into 445 times, that's 400. Subtract 40, bring down a 0. Well, finally, 5 times again. There's your 400. Nothing left over, nothing but zeros to bring down, and I get a negative 3.55 for my answer. It's a little sloppy. Hopefully you can read that all right. Now this same approach works with inequalities, just like it did with the equations. In this case, I have 1 decimal place. I don't have any. I have 1. 1's the most. So like in example B, I'm going to multiply by 10. And that's not going to affect the inequality sign. It's going to stay greater than. I'm multiplying by a positive, which is kind of nice. Over here, I'm going to distribute 10 times 1.2n. That's 12n. Minus 10 times 8 is 80. Greater than 16. Now we're on our way. I'm going to add 80 to both sides. And I have 12n is greater than 96. I'm going to divide both sides by 12. I'm running out of space. That's the only reason why I'm attaching it. And I have n is greater than, looks like 8. And that's my answer. All right. If you don't want to deal with the fractions, if you don't want to deal with the decimals, then take these suggestions. Fractions multiplied by the least common denominator. Decimals multiplied by the appropriate power of 10. That will eliminate those decimal places, so you'll end up with an equation that won't have any fractions or decimals, or an inequality without any fractions or decimals. It takes a little bit of time to get good at this, so remember, practice, practice, practice.